Have you ever really thought about how incredible it is that we can perform surgery with just a beam of light? I mean, it sounds like something straight out of a sci-fi movie, but it's happening every single day in modern eye surgery. Today, we're going to get into the amazing physics behind the lasers that can literally reshape our vision with microscopic precision. So, let's dive right in.
So, that's the big question, right? How in the world does something as seemingly intangible as light become a surgical tool? Well, the answer isn't just one magic laser. It's actually a team of two highly specialized lasers working together, and here's the kicker. Each one has a completely different job to do.
So let's meet our two specialists. On one side, you've got the Excimer laser, which you can think of as the molecular reshaper. And on the other, the femtosecond laser, our microscopic cutter. They are not the same thing at all, and figuring out what makes them different is the whole key to understanding how this incredible surgery is even possible.
Okay, first up, the excimer laser. Its main job isn't to cut, but to reshape tissue. So don't think of it as a knife, think of it more like an unbelievably precise, molecular-level sandblaster. And how it works is just fascinating.
It all comes down to a process called photoablation. You see, the excimer laser zaps the tissue with high-energy ultraviolet photons. But here's the cool part. These photons don't burn anything. Instead, they hit the tissue with such a specific amount of energy that they instantly break the molecular bonds holding it all together. The tissue just vaporizes. A tiny layer vanishes with practically no heat and no damage to the stuff right next to it.
Let's walk through that. A photon, at a very specific 193 nanometer wavelength, hits the cornea. Its energy gets absorbed, and poof, the connections holding the molecules together are just gone. That tissue is ablated away with stunning accuracy, leaving everything around it completely untouched. It's the absolute ultimate in precision removal.
So why do this? What's the point? Well, this exact kind of reshaping is what you need to fix the curvature of the cornea and correct really common vision problems, like nearsightedness, farsightedness, and astigmatism. By chipping away tissue in these tiny increments, a surgeon can sculpt the lens of your eye to perfection.
All right, now for our second specialist, the femtosecond laser. This laser has a totally different mission. It's not a reshaper, it's a separator. It's designed to make these incredibly clean cuts inside the corneal tissue without ever touching the surface. Wild, right?
The femtosecond laser uses a process called photodisruption. So instead of vaporizing tissue from the top down, it focuses an intense pulse of energy to a tiny point inside the cornea. This creates a little bubble of plasma that expands and literally pushes the tissue apart. So, by creating thousands of these little bubbles in a perfect line, you can draw a perfect separation, kind of like the perforations on a postage stamp.
Now, the secret ingredient here is unbelievable speed. A femtosecond, that's a quadrillionth of a second. It's so fast, it's hard to even wrap your head around. The laser pulse is so insanely short that the energy has zero time to spread out as heat. It gets in, does its job, and gets out before the surrounding tissue has any idea what just happened.
So here's how that plays out. The laser focuses deep inside the cornea, it creates that little plasma bubble, and that bubble physically separates the tissue. And the surgeon can program the laser to place these bubbles at an exact depth, in any pattern they need, creating a perfect three-dimensional cut from the inside out. Okay, so now that we've met our two specialists, the reshaper and the separator, let's see how they actually work together on the same team. Because it's their collaboration that has completely revolutionized eye surgery as we know it. And their greatest hit, their #1 performance together, is in one of the most common surgical procedures in the world, LASIK. This surgery is the perfect showcase for watching each laser play to its unique strengths.
This is where it all comes together. First, the femtosecond laser, our precise separator, goes in and creates a perfectly thin, circular flap in the top layer of the cornea. Then, the surgeon just gently lifts that flap like a little lid. That's the cue for our molecular scalpel, the excimer laser, to step in and do its thing, using that photoablation to precisely reshape the tissue underneath. Once that's done, the flap is laid right back down. It is an absolutely elegant two-step masterpiece of physics.
So it's really important to get that these aren't just two lasers doing the same thing in a different way. No, they are fundamentally distinct technologies that, when you put them together, give surgeons a level of control that was just unimaginable with old-school mechanical tools. And this table really just boils it all down. The excimer uses a chemical-like process, photoablation, to remove tissue and reshape things. The femtosecond uses a mechanical process, photodisruption,
to separate tissue and create flaps or incisions. They're two totally different tools for two different but perfectly complementary jobs.
So what does all this precision really mean for patients? Well, it means surgeries are way more accurate and predictable. It means a huge drop in complications compared to the old ways of doing things. And it actually allows for treatments that are completely customized to your individual eye. It is, no exaggeration, the foundation of modern vision correction.
So let's just think about that. We have lasers that can reshape and separate human tissue at a microscopic level with almost zero collateral damage. This tech has totally transformed ophthalmology. It really makes you wonder, with this kind of precision now at our fingertips, what other fields, in medicine or maybe even in manufacturing, will this incredible laser teamwork reshape next?